Hey friends, welcome to the next day of Unit 3. Today we're going to specifically be looking at arithmetic sequences. If you look at the very beginning of this page, there's a review of average rate of change. So go ahead, pause the video, try to work out numbers 1, 2, and 3, and then come back and check your answer with mine. Alright, so hopefully you took a second and you filled this out. Go ahead and check your answers with mine. Hopefully look at all the things that I have written. Hopefully you guys did really well on that. Alright, so now we are going to move on to the actual notes for today. Today we're going to talk about arithmetic sequences. So I'm going to write a sequence here. So 1, 3, 5, 7, ... means continue on in this pattern. There's more, keep going. So this here is an example of an arithmetic sequence. And what that means is it's a sequence created by adding or subtracting the same value to determine the next value. Okay, so that means either you add the same number every single time or you subtract the same number every single time to get to the next term. Okay, so I'm going to give you some vocab here, and I'm going to talk about the two types of formulas that we write with arithmetic sequences. So let's start with the stuff over on the right hand side. So A sub n, that's how we say this. This is said A sub n. Okay, what this means is this is the value of the nth term. Now, what does that mean? Good. So let's say I wanted to know the 12th term of this sequence. Then this would be A sub 12. That would give us the 12th value in this sequence. So go to the 12th term and we get that value. Okay? A sub 1, this is going to be the value of the number 1 there means the first term. So this should be the first number in the sequence. So like here, A sub 1 is 1 in this case. Okay. Whenever we see an A sub n minus 1, this means the value of the previous term. Okay, that means the term before the one that we're talking about. Okay, so like if we were talking about the n being the 12, then that would give us 12 minus 1, which is 11. So therefore we get the 11th term, which is the one before the 12. Okay, and then D, this is what we call the common difference. The common difference. Okay, this is what we add or subtract each time to get to the next term. Okay, so see, we said it was an arithmetic sequence because we added or subtracted the same thing. That number that we add or subtract, that's called the common difference. And I do want to add another one down here. So please add this in, n. Okay, n, this is the term we are looking for. It's the term that we're looking for. So if I ask you for the 12th term, that means wherever the n is, whether it's little or big, you need to put the 12 there. Okay. Now, we've got two equations over here. Explicit formula and a recursive formula. The explicit formula here is written this way, but you also may see it written as A sub n equals A sub 1. Remember, that's the first term, plus n minus 1 times d. Sometimes the d is written in front of the parentheses and sometimes it's written at the end. It's important that you just remember that that means you multiply the n minus 1 times the d with distribution. Okay? Then the other formula that we have is called the recursive. That means to get to the next one. So to get the term that we're looking for, okay, the value of the term that we're looking for, we need to take the value of the previous term and add our common difference. Okay? We're going to see what this looks like as we work some examples. So let's go on to the next part. We've got a couple examples here, and we're going to walk through them and make sure that we completely understand all that we are doing. So the first one has a sequence, 5, 8, 11, and 14. Okay? So the first thing that I always recommend doing is find if there's a common difference. So let's see, is this arithmetic? Are we adding or subtracting the same thing every time? So as easy as, how do I go from 5 to 8? Well, that's easy. We just add 3. How do we go from 8 to 11? Well, we still add 3. And how do we go from 11 to 14? We add 3. So if we can say that yes, we're doing the same thing every single time, then we do have a common difference. So D is equal to a positive 3. We're adding 3 every single time. Okay. Now, the first term, we note that with a sub 1. Well, what is the first term of this sequence? The first term is 5. So a sub 1 equals 5. Okay. So now what we're going to do is we're going to find the explicit formula. So if you remember from on the other page, the explicit formula said a sub n equals a sub 1, which we just said was 5, plus the common difference, which is 3, times n minus 1. So just so you guys see, this is what the formula on the other page said. And all we're doing is taking a sub 1 and plugging it in, and taking our d value and plugging it in. Okay? Now, we can't just leave it like this. We need to simplify it. So thinking through PEMDAS, PEMDAS says you have to multiply before you can add and subtract. So we need to make sure that we distribute the 3 first before we combine the 5 and the 3. So a sub n equals 5 plus 3n minus 3. And now we can combine whatever like terms we have. So 3n and then 5 minus 3 gives us a positive 2. This is what we call the explicit formula. Now what's nice about the explicit formula is we can use that to find any term in the sequence. So if I asked you for the 100th term, we could find that. And that's exactly what we're going to do down here. So I'm going to jump to this part real quick and then we'll go write the recursive. This one says find a sub 12. So here the n is 12. That means the 12th term. So we want the value of the 12th term. So all we're going to do is take this explicit formula that we just wrote, and we're going to put a 12 everywhere that n is. So I get 3 times 12 plus 2. And this is just easy. Plug it into the calculator or do the math. 3 times 12 is 36. 36 plus 2 is 38. So a sub 12 equals 38. Okay. Now we're going to go to the recursive. The recursive formula is really nice. So the recursive formula says we need to know what the first term is, and then we need to fill in this. So a sub n minus 1 plus d. So on this one, we plug the d in here, and we plug the a sub 1 right here. Okay. So I'm going to go do that over here. So it's a sub n equals a sub n minus 1. That doesn't ever change. The only thing that changes is the common difference, so plus 3. And then the other part is we need to make sure we state the first term. So all of this gives us the recursive. This just tells us that we can find the next term by taking that first term and adding 3 to it. Okay, so this is only helpful if we're finding the next term. Okay. Let's look at the one over to the right. It says -7, -5, -2, 2, ... So we're seeing what is going on between each one. So how do we go from -7 to -5? We add 2. how do we go from -5 to -2? This is add 3. Now wait a minute. Are those the same number? No, they're not the same number. That means this is not arithmetic. So let's say not arithmetic. All right, that means we can't find the explicit or the recursive or the 14th term, so now we get to move on. All right, so let's look at the next one. This sequence says -11, -21, -31, -41. So we need to figure out how to get to the next number. So how do we go from -11 to -21? If this is difficult for you guys to figure out, take the second term and subtract the first term. Okay, so you can use your calculator to do that. Okay, I need to take the second term and subtract the first term. So if we do that over on the side, -21 minus -11, minus negative turns positive. So if we add 11 to -21, we get a -10. That means we're subtracting 10. Well, are we subtracting 10 more here and another 10? We sure are. So our common difference is subtracting 10. Our first term, so a sub 1, is -11. Now we can go ahead and write our explicit. So a sub n equals the first term, -11, then our common difference, which is a -10. So instead of using a plus sign, now I'm using a minus sign, times n minus 1. So now we're going to distribute the -10 and then combine like terms. So -11, distribute this, so -10n, negative times negative is a positive, and now we can combine our like terms. So a sub n equals -10n, and a -11 plus 10 is a -1. Okay, our recursive formula, remember we need the first term, which is -11, and then we need the recursive formula, which says a sub n equals a sub n minus 1 minus 10. That's the common difference. All right, so when we go and do the bottom part here, find a sub 16, this means what's the value of the 16th term. So we're going to take a 16 and plug it in for all our n's. So a sub 16 in the explicit formula is equal to -10 times 16 minus 1. This gives us that the 16th term is going to be equal to -161. Okay. All right, I did 2 of them. I want you to go ahead and try the next one. So go ahead, pause your video, try to do the next one, and then come back and see what I got. All right, you should have your common difference is -10. The first term, a sub 1, is 17. Your explicit is a sub n equals -10n plus 27. Your recursive is a sub 1 is equal to 17, and a sub n equals a sub n minus 1 minus 10. Then the 18th term has a value of -153. All right, so we're going to move to the next one. We're going to do this one pretty quick. So the common difference here, we're going to see that every single time we are decreasing by 3. Our first term is -10. Our explicit formula, a sub n equals -10 minus 3 times n minus 1. So a sub n equals -10 minus 3n plus 3. A sub n is -3n minus 7. Okay, our recursive is the first term, -10. Then a sub n equals a sub n minus 1 minus 10, and then the 12th term, when we plug in a 12, we are going to get a -43. Okay, go ahead and try the next one. All right, you should notice this one's not arithmetic. All right, we're going to take a little break and then we'll come back. See you later.